Hi, welcome back to Moose and Chemistry. You've been studying stoichiometry by now, and do you know that there's a gas stoichiometry? So this is going to be our lesson in gas stoichiometry. So given the problem, the reaction 2H2 plus O2 yields 2H2O, pretty simple equation, just making hydrogen plus oxygen makes water, or I would say dihydrogen monoxide. Given 10 liters of oxygen and excess of hydrogen, how many liters of water can be made? So what we're saying is that hydrogen is our excess, so we don't use it, and oxygen is our limitant reactant. So this is our excessive reactant, and this is our limitant reactant for oxygen. So we're always use the limiting reactant to determine things. Also, you need to know that there are exactly 1 mole equals 22.4 liters of any gas. Okay, so now let's go ahead and set this up. So we're given 10 liters of oxygen, and we want to use our 1 mole of O2 to 22.4 liters. Okay, so we're going to convert our liters of oxygen into moles of oxygen. Then we want to convert using the molar ratio, which we learned earlier in stoichiometry. Okay, there's a 1 mole here, so there's 1 mole of O2 to, hang on for a second. There are 1 mole of O2 to 2 moles of H2O. So we're going to put 2 moles up here, and that converts from moles of oxygen to moles of water. But we don't want moles of water, we want liters of water. So to do that, again, we have to use the molar ratio of 1 mole of H2O to every 22.4 liters of H2O. Now we're ready to do that. So let's go ahead and plug this in our calculator. First, we cancel out our common units. So our common units are canceling out. So go ahead and let me plug these numbers in. So it's 10 divided by 22.4, okay, times 2, okay, times, again, 22.4, and that would give me exactly 20 liters of dihydrogen monoxide or water. Okay, let's look at another problem using gas stoichiometry, but a little bit harder, okay? So let me erase all this and then we'll write a new one. Okay, this problem's really quite a bit different. Okay, in this case, we're going to have to do a couple of things, okay? First of all, let's read the problem. How many liters of water can be made from 100 grams of oxygen gas with an excess of hydrogen at a pressure of 141 atmospheres? Okay, so a couple things we need to know. First of all, we've got grams, and we can't use grams. We need to put everything into moles. So what we're going to do is we're going to go ahead and we're going to convert grams of oxygen into moles of oxygen. So we'd go 100 grams of O2 times 1 mole of O2 divided by 32.00 grams of O2. Where did that 32 come from? Well, remember that oxygen has an AMU of 16.00 grams per mole. Actually, it's 15.99, but we're just rounding it off. But since we have 2 of these, that would give us the 32. Okay, just take a look at that for a moment. Now I'm going to get rid of it. All right, so now when we do that, that's going to convert into the following. Let's see here. We take 100 divided by 32.00, and that gives me exactly 3.125 grams. 3.125, not grams, but moles of O2. Okay, now, also notice that we have temperature, and it's in Celsius. So this is going to be a PV equals nRT problem. So we're going to kind of use the ideal gas law for this one. So what we need to do is convert Celsius into Kelvin. To do that, remember that Celsius, or hang on a second, Kelvin equals Celsius plus 273.15. Okay, so K equals 70 plus 273.15, and K is going to equal, so let's put that in the calculator, 70 plus 273.15, and that's going to give us 343.15 K. So we go 343.15 K. Okay, great. Now, our R value is our gas constant, so it's going to be 0.0821 liters times atmospheres over moles times Kelvin. Okay, so I think we're about ready here, except for one other thing. We need to know, we know our mass, we know our moles, right? Okay. Now let's see here, or do we? Well, we got the moles of oxygen, but we need to know the moles of water, because we're finding water, right? Oh, that's right, we're finding water. So now we have moles of oxygen, so before we start this equation, we're going to have to know the equation. So we get 2H2O plus O2, our chemical equation, that is. It's going to give us 2H2O. All right, now the mole ratio between oxygen and water is a 1:2 ratio. So we're going to take our 3.125 moles of oxygen and turn it into moles of water. So we're going to do that by setting this up like that. So let's just take a moment for you guys to see what I did. I took the moles of oxygen, put it underneath, and I want to turn it into moles of water because we're looking for liters of water. So once we have the moles of water, we can convert it into liters. All right, so now we cancel this out, cancel that out, and this gives us a new number here. So we're going to go 3.125 times 2. This gives me 6.25 moles of H2O. Okay, now we're ready. So first of all, we're looking for liters because that's volume. So V equals nRT over P. All right, so V equals N is our number of moles. Okay, that's that right there. That's our number of moles. So that's going to be 6.25 moles. Okay. All right. Times our R value, which is right here. That's our constant. 0.0821 liters times atmospheres over moles times Kelvin. Times our temperature, which is right here. So our temperature is going to be 343.15 K. It's getting kind of crowded in there. Divided by our pressure. Now our pressure was 141 atmospheres. So let's look what cancels. That cancels, that cancels. Moles cancel, moles cancel. Kelvin cancel, so all that's left is liters. So let's multiply the top first. So 6.25 times 0.0821 times 343.15. This gives me roughly 176.078, and this will be liters on top, and divided by 141. So let's see what our new number is going to be. This is going to be pretty interesting. A lot of pressure there. So we have 176 divided by 141, and that's going to give me exactly 1.25 liters. Okay, and that's our answer. Hope you guys have an awesome day, and be snarly, and we'll see you back here at Moose in Chemistry.